Hello, and welcome to this introductory series on GIS using ArcGIS with SpatialNnachi, where space meets place. I'll be your guide as we explore the world of geographic information systems in a clear, practical, and hands-on way. In the first module, we'll walk through the foundation of GIS, what it is, its main components, the types of data and file formats it uses, and how it's transforming decision making across different sectors today. So, what exactly is GIS? GIS, or Geographic Information System, is a powerful technology that helps us capture, store, analyze, and visualize data that has a location tied to it. In simpler terms, it answers questions like where is something located, what's around it, and how do different features relate in space. If you've ever used Google Maps to find the nearest clinic or check traffic, you've already interacted with GIS. It's working behind the scenes, combining maps with real-time data to solve real-world problems. So whether you're new to GIS or looking to sharpen your skills, you're in the right place. Now, let's break down the 5 core components that make GIS effective. First, hardware. This includes the physical tools you use, like your laptop, GPS devices, mobile phones, and even scanners. These are what runs the software and collects or processes the data. Next is software. Software is the engine of GIS. These tools help us create, visualize, analyze, and share geographic data. Example is the ArcGIS by Esri. Third, we have the data. Without data, GIS is just an empty shell. This includes shapefile, satellite imagery, spreadsheets, and all the information that tells us what is where. Then comes the method. These are the procedures and models used to solve spatial problems, like how we classify land cover, analyze deforestation trends, or map out urban growth. Finally, people. People are the brain behind GIS. Analysts, cartographers, researchers, even students who ask the right questions and interpret the results. Together, these 5 hardware, software, data, people, and method make GIS a powerful tool for solving real world challenges. Now, let's talk about GIS data types, which forms the backbone of any GIS project. First, we have spatial data. This is data that tells us where something is located on the Earth's surface. It's all about location, shape, and geographic position. Spatial data comes in 2 main formats. The first is vector data, which uses points, lines, and polygons to represent real-world features. For instance, a point could be a borehole or a tree. A line could represent a river or a road, and a polygon could be a farmland or a lake. Vector data is best for features with clearly defined shapes. The second is raster data, which looks more like a grid made up of pixels, and each pixel contains a value. It's ideal for continuous data, things like elevation, land cover, or temperature. Next, we have non-spatial data, also known as attribute data. This is the descriptive information that tells us more about our spatial features, like the population of a city or the name of a road. It's stored in tables and linked to the spatial data through a common identifier. So in summary, GIS brings together both location-based and descriptive data, allowing us to analyze not just where something is, but also what it is. Let's break down the core concepts that makes GIS work. First, we have the coordinate system and projection. This defines how we flatten the Earth's curved surface onto a map, like choosing between a globe or paper. Layers are like transparent sheets, one for road, another for river or population. Stack them together and you get a full map. A datum is your map's reference point. It tells the system where 0 is on the globe. Topology sets rules for how features relate, making sure road connects and boundaries don't overlap. It helps keep map clean and logical. Digitization is the process of converting old paper maps into digital data, drawing points, lines, or areas on a screen. Georeferencing aligns scanned images to real-world coordinates so they fit perfectly on your base map. Spatial analysis lets us talk about powerful questions like what's near what or where something is happening most. Symbology and map design gives meaning to what you see. Rivers in blue, roads in black, making your map easy to read and visually appealing. And finally, a geodatabase is where all GIS data is stored. Think of it as a digital cabinet holding your maps, tables, and features. Together, these concepts are the backbone of every powerful GIS project. Now, let's briefly go through some common file formats used in GIS. These formats helps us store, manage, display both spatial and attribute data in our projects. 1. Shapefile. This is one of the most widely used vector file formats. It stores geometries like points, lines, and polygons, but it's just one part of a group of files. Second, KML. Used in Google Earth, it's great for sharing location, routes, and polygon. XML. This is a flexible text format that stores metadata and configurations. It helps describe how GIS data should be structured. DBF. This file holds the attribute data for shapefiles, essentially the table behind the map. It links each feature with its descriptive information. TIFF. This is common raster format, often used for satellite imagery or scan map. MXD. This is ArcMap project file. It saves your entire map view, that is your layer, symbology, layout, everything. Think of it as a workspace. GeoJSON is ideal for web mapping. GIS data is collected using various tools, grouped into 5 categories. 1. Spatial data collection instruments. This captures location, shapes, and size of features on the Earth. We have the ground-based, we have the airborne, and we have the satellite-based. Second, attribute data collection instrument. It gathers descriptive and socioeconomic information. Examples are questionnaires, interview, ODK. Remote data collection tools. Allows for data gathering without field visits. Example is the OpenStreetMap and Google Earth Engine. Digitization tool. What they do basically is to store, edit, and analyze, visualize GIS data. Example is the ArcGIS suites, Google Earth, Excel, QGIS, and the likes. These are examples of these collection kits: laser rangefinder, drone, satellite, theodolite, GPS, and the like. Now, let's explore how GIS is used in the real world. In urban planning, it helps design cities, plan roads, and manage population growth. For disaster management, GIS maps risk zones, predicts impact, and supports emergency response. In agriculture, it monitors crops' health, soil, ensuring food security. In environmental monitoring, uses GIS to track deforestation, pollution, and land changes. In public health, it maps disease outbreaks and improves healthcare access. Transportation and logistics benefit through route planning and traffic analysis. GIS also aids water resource management, from irrigation planning to groundwater mapping. In oil and gas, it guides exploration and reduces environmental risk. Land administration uses GIS for property boundaries and title management. And for utilities, GIS helps manage power lines, water systems, and telecom networks. From planning to protection, GIS supports smarter decisions everywhere. In conclusion, GIS is more than just creating maps. It's about using location-based data to make smarter evidence-based decisions. In this module, we explored the foundation of GIS, what GIS really is, its core components, the different data types and file formats, key concepts like coordinate system and spatial analysis, tools and instruments used for data collection, and real-world application across fields like environment, health, disaster management, and more. By now, you should have a solid understanding of these fundamental concepts and how they all come together to make GIS a powerful tool for solving spatial problems. So that's a quick introduction to GIS, what it is, why it matters, and the tools and data that powers it. In the next video, we will jump into ArcGIS interface and begin some hands-on map exploration. And guess what? That's the fun part. If you have any questions, suggestions, or topics you would like us to cover, feel free to drop them in the comments below. And don't forget to like, subscribe, and hit the notification bell so you don't miss the next class. The journey is spatial. Insight is global. See you in the next class. Cheers.